When you think about healthcare, you could simplify it to like, well, we have medicines and we apply to patients, but then questions come in like, well, which medicines have the biggest impact? Some medicines help some people, but they don't help other people. Now we're looking at subgroups. And then also, how do we produce those medicines, right? Active learning is essentially trying to answer the question of which data point should I collect next? What is the next best experiment? And so active learning means you actively learn in a most efficient way. For example, to improve a statistical model, the method is something called design of experiments, which is a clever and statistically validated way to navigate a high-dimensional space. But it's not as accessible to most people as it seems, because you have to make a lot of design decisions. You have to think about the statistics and the theory there if you want to do properly. The attractiveness of machine learning and active learning specifically here is that it trades off that interpretation you get with design of experiments with a very simple but powerful method. Because we can interpret active learning methods to some degree, but their power really is just in being this kind of black box where you ask it the most efficient data point and you just trust it and you go with the recommendation. It doesn't have to replace what you're thinking and your chemistry knowledge. And in fact, it should just supplement it and guide you. But like those recommendations are the best we can generate with math and statistics today. And so because it is such a one-click solution, you ask the model, it gives you a number, you make up your judgment. I think it's going to push through and provide a lot of benefits that the design of experiments just couldn't do, just because it's a bit too complex and not as powerful. Do scientists intrinsically not need statistical expertise? Or do we not have enough statistical scientists to supply for that demand? That's somewhat always the question of technology adoption and innovation is, do people just not understand it, or does it not provide the value? I think it's a mix. I think on the one side, we need more statistical education in fundamental sciences like biology and chemistry and so forth. But on the other side, I think we also need simpler methods, like the expectation that everyone can go and run really high performance DOEs is just not true. That's not the reality that we see in the lab. That leads also to a new concept that we're introducing at Matterhorn Studio, which is something called T-shaped Bayesian optimization, which is basically the idea that for the majority of people, we need simple, off-the-shelf, reliable methods. So that's the horizontal part of the T. But then if you want to go into the specifics and if you don't want to do the high performance stuff, that's when you get into the vertical part of the T, like more advanced methods where you need the capacity and the talent to understand those in your organization. And so I just focus now on how much data do we have and how complex is the problem. But statistics is more about that. There are questions of like, what do you measure? What are your inputs? What's the modality? How do we quantify biology anyway? Are we going to take pictures of cells and stuff like that? And people are trying a lot of things, but it's not defined. It's not settled. And all of these are incredibly complex, exponentially complex more problems than what we faced so far. And the question is, does our success actually extrapolate into those spaces? And my theoretical education tells me no. So we need another miracle.
I worked a lot with medicinal chemists, and we try to introduce AI methods with them. And very often when we were sending them, like the output of an AI model predicting like this is the next molecule that we need to synthesize. And they would look at it and say, I don't like it. My intuition tells me it's the wrong one. And I was telling them, well, of course, because it comes from a computer or from a mathematical model. So it doesn't quote unquote think the way you think, but maybe we should give it a try.
I talked to a pharma company last week and they were like, we've trialed AI methods. They don't work for us. We're going to just keep playing the lottery as we do right now with like computational modeling, medicinal chemists. How do we, between the useful expertise of a chemist and then the bias, the really bad bias of a chemist of like, oh, well, we've always done it this way. That's not a good answer to a computer recognition. Theoretically, I'm actually part of the camp of like, let's do everything the machine learning model says and not have the chemist do a pre-selection. Practically, that is not the world we live in. There's no evidence that we will fully automate the human or the chemist away from these processes. Maybe there won't be part in selection the way we think of it as we do today. And maybe there won't be, and that's a good thing because we get rid of these biases that you just mentioned. But I don't think we'll get rid of the human. I think we shouldn't, because it's a crucial part of that. It just might play a different role than that's obvious to us now. I think what's going to continue to be important is number one, lab automation. So we're speaking of having lab setups that not necessarily closed loop, but just taking away, first of all, the complexity of running experiments by hand in some cases, but also like having better reproducibility. And then, of course, I think bringing all of this together, lab automation and machine learning and algorithms is of course the closed loop lab, so lab in the loop. I think we're going to see more iterations of those. They won't be perfect, but they will get us closer to this kind of lab where chemists and scientists can focus even more on the science and the modeling. And so I think the lab in the loop is probably going to be the name of the game in the next 5 to 10 years. AI is called AI until it solves a problem, then we just call it software.